This is Module 15, Section 8.3. We're continuing with our discussion of functions in this section, and we're going to start today with polynomial and rational functions. Evaluating polynomial functions. In Section 8.2, function notation was introduced and used to evaluate expressions. Now we are evaluating a specific type of expression, a polynomial expression. Note that p of x is often used instead of f of x to represent a polynomial function. If the problem involves a real-life polynomial, another letter may be used to represent that specific type of function. So for example, let's say that you're given this problem. If p of x equals 4x cubed minus 2x squared plus 5, find p of 3. All right, so this is just exactly the same thing we were doing in the previous section. When asked to find p of 3, what that means is to let x be 3 in the polynomial wherever x appears. And so wherever x appears, we're going to replace that with 3. All other terms remain the same. Simply do the math. So we've got 4 times 3 cubed minus 2 times 3 squared plus 5. And now it's an orders of operation problem, so do the exponents first. We've got 4 times 3 cubed is 27, minus 2 times 3 squared is 9, plus 5, equals 4 times 27 is 108, minus 2 times 9 is 18, plus 5. And bringing that up here, now we've got subtraction and addition, work left to right. 108 minus 18 is 90. And 90 plus 5 for our final step is 95. So evaluating polynomial functions really is the same thing we were doing in the previous section. So let's look at a real-life application. This problem says a projectile is fired upward from the ground with an initial velocity of 300 feet per second. Neglecting air resistance, the height in feet of the projectile at any time t can be described by the polynomial function h of t equals negative 16t squared plus 300t. Find the height after 3 seconds. All right, so what they tell you here is that h represents the height of the projectile in feet, and t represents the time after the projectile is shot into the air in seconds. And they give you the equation h is a function of t equals negative 16t squared plus 300t. Now you'll notice they give you this information here, but the only reason they gave you that information is to explain part of that particular equation they give you. In terms of needing that to answer the question, you do not. They could have left that information out and just given you the formula. What they're really asking you is this. They give you a time value, so they tell you that t is equal to 3 seconds. They simply want you to find the height at that particular time. In other words, they want you to find h of t. Okay? So the height at a time of 3 seconds is given by this equation. We want to put 3 in for all of the time factors. So we've got negative 16, 3 squared, plus 300 times 3. That's equal to negative 16 times 9, plus 300 times 3 is 900. Do your multiplication step. Negative 16 times 9 is negative 144 plus 900. And if you do that addition step, you find that after 3 seconds, this particular projectile is at 756 feet. So the height at 3 seconds, or the height at time t, is equal to 756 feet. Evaluating rational functions is much the same with one twist. Rational functions are simply functions that contain at least one fraction of the form p of x divided by q of x, where p of x and q of x are polynomials that we just talked about, and q of x cannot be equal to 0. So for example, let's look at the function x squared plus 3 divided by x minus 5. We have a polynomial up top, a polynomial on the bottom, and the function together as a fraction is a rational function. Now I'm going to rewrite that function here since it was on the previous slide. We're looking at f of x is equal to x squared plus 3 divided by x minus 5. Okay, the thing you have to be careful of when evaluating rational functions is that the denominator of any fraction cannot be 0, as this gives you an undefined term. In the above example, which I just rewrote right beneath there, x cannot be 5, because in the denominator, 5 minus 5 would give you 0. And remember from pre-algebra, any number, let's say 9, any number divided by 0 is an undefined fraction. You are not allowed to have 0 in the denominator. Therefore, we can express this by saying that the domain, which is simply your x values, of this function is any value of x except 5. You cannot let your domain be 5 because then you get 0 in your denominator. We can write the domain in this type of set notation called set notation or set builder notation. Okay? It is read from left to right with the variable being used to represent the solution written first, followed by a vertical line, which is right here, a vertical line that is read such that, and the restrictions on the solution set written last. Therefore, that set notation in the middle of the page is read as the set of numbers x, because that's the variable in our problem. If that was an a, then it would be an a there, or a b, or a y, or a z. The set of numbers x, such that x is a real number, and x cannot be equal to 5. That's a way of representing a domain that has a restriction on it. So let's look at these two types of problems you might see in homework. If f of x is equal to x squared plus 3 divided by x minus 5, find f of negative 3. Okay, so this is simply an evaluation problem, not unlike the evaluation problems we've done prior to this in other sections. We simply want to let negative 3 represent all the x's in the rational function. So we've got negative 3 squared plus 3 divided by negative 3 minus 5. And do the math. Negative 3 squared, negative times negative is a positive 9 plus 3 divided by negative 3 minus 5. Okay. Now when you have a fraction, there are understood grouping symbols around top and bottom. That division sign is the very last thing that you will do if it's written as a fraction. So 9 plus 3, we're going to simplify that first, and that gives us 12. Negative 3 minus 5 is negative 8. And then, of course, as always, you want to reduce fractions. You can take out a common factor of 4. 12 divided by 4 is 3. Negative 8 divided by 4 is negative 2. And therefore, f of negative 3 for this particular function is negative 3 halves. Now the second example also is a evaluate problem, but it also asks you to find the domain. Okay? If g of x is equal to x minus 4 divided by x plus 7, find the domain of g of x and find g of 0. The one thing that's going to keep you from picking any value of x you want for this particular function is that denominator. We said that when you have a denominator of a fraction, that denominator cannot be 0, because if you have 0 in your denominator, you have an undefined fraction. So say exactly that. Take the entire fraction when you're asked to find the domain. take the entire fraction and say that that denominator, x plus 7, cannot be 0. Solve for x. So if you subtract 7 from both sides, x cannot be negative 7, because if you put negative 7 in here, you can see that that denominator equals 0, which is not allowed. So let's write that domain in set builder notation. Set builder notation says that the domain of this particular problem is represented by the variable x, such that x is a real number, but there's a restriction, and x cannot be negative 7. So that's your domain. Now, find g of 0. To do that, we're simply going to put 0 in for wherever x appears. We've got 0 minus 4 divided by 0 plus 7. That gives us negative 4 over 7, and g of 0 is equal to negative 4/7. The reason I chose to do this problem is sometimes with rational expressions, students think that you can never let x be 0 because that will automatically give you a 0 in the denominator. Well, notice that is not true. X could be 0, that's fine. 0 plus 7 gives you a 7 in the denominator. In this particular case, the thing that x can't be is negative 7. So don't just assume that x can't be 0 when you have a fraction. It depends on what else is in the denominator of the problem. All right, let's do one more example. The revenue from the sale of a certain type of MP3 player at a discount store is approximated by the rational function r of x is equal to 500 times x squared divided by the quantity x squared plus 3, where x is the number of months since sales began, and r of x is the total revenue in dollars. So I'm just going to make a note of that here. X is the number of months since sales began, and r of x is the total revenue. Revenue is just the amount of money they made in dollars. What is the total revenue at the end of the first month? So the first question says, let x be 1, that's 1 month, and see what your revenue is. Find what r is. So r of x is equal to 500 times x squared over x squared plus 3. R of 1 then, the revenue after 1 month, is going to be 500 times 1 squared divided by 1 squared plus 3. Again, remember there's understood grouping symbols there. That's going to give us 500 times 1 divided by 1 squared is 1 plus 3 is 4. And 500 divided by 4 is exactly $125. So after 1 month, this particular discount store made $125. Now the second part of this, or the last part of this question, says, what is the revenue at the end of 12 months? So we're going to let x now be 12. So we've got revenue at 12 months is equal to 500 times 12 squared divided by 12 squared plus 3, which gives you 500 times 144 divided by 144 plus 3, which then gives you 500 times 144 is 72,000. Divided by 144 plus 3 is 147. And if you put that in your calculator, you get 489.7959 rounded off. You're asked to round to the nearest cent, though, so we're going to round that off to the hundredths position. And since this value is a 5, we're going to round up. And so we get a rounded answer of approximately $489.79. $1,000,000.80 at the end of 12 months for the sale of this particular MP3 player. Which brings us to the end of Module 15, Section 8.3. You should now complete the homework for Module 15, Section 8.3 found in My Math Lab. And when you have successfully completed the above homework, proceed to the video for Module 15, Section 8.4.